HuggingFace 2025, 11th of April. Transformer. This is paper, the table 1 and table 2 on Transformer, which is the other thing that most important and emphasize. If we see here, there is complexity per layer and maximum per length, which is O1 self-attention compared to recurrent. This is the most big thing in Transformer, which is RNN. It needs long-term dependency, but Transformer, they solve it by put input all together and calculate the query and key and value together. But it's also, we need mask in Transformer because in RNN, one by one come out to predict next sentence, next word in sentence, but in Transformer, everything comes in together for unit masks. So we can distinguish self-attention and other attention based on where query key value comes from. And in softmax, there was we use exponential function, and there was important impression which was scaling. There's three consideration need for attention, which is first feedforward, which have activation function in the middle, so we are able to do non-linear transformation, and attention is for linear operation. We can think of what is the difference between in matrix level difference. And second thing is we need mask, as I told you. So we use auto regressive training calculation able to we will look for it later at Transformer HuggingFace. And third thing is input order sequence, because we put input together, we can teach model by learning or using absolute or relative path for Transformer to understand it. Later, we'll also talk about how RNN come back again because of complexity per layer problem. Okay, so Transformer, just think of there's X and X1, there's sentence. Then we will first change it to a feature vector, which is our output that we wanted. There will be query K3. Then we will do, we'll calculate things together. I didn't understand this part as mathematically. This is one thing we should look for. So when making neural network, we should determine input and output format. We call it stem block or embedding, which is input in tensor format. So what is important is feature vectors dimension. If we determine it, then we can determine the embedding layers dimension. Then after that, there will be an building block. In Transformer, we use self-attention and feedforward network. Yeah, self-attention and feedforward network. Yeah, this is about attention mechanism. So this is how part of core. So there will be Z N equals to B and C, which will be B was batch size and the token size and channel size. And in multi, yeah, and if I show you the big picture, and when we do training, it is also important to use residual connection and layer normalization. Residual connection and layer normalization technique is used. And currently every uh, neural network these days use this technology, and we should change it to output vector format. And in probabilistic model case, they will give model probability of each. So in fact, if you calculate KB, there will be output vector format Y. We can see how it works together again by seeing. Okay, so multi attention. What we do is like so there was 3 dimension, B and C, C is channel. We separate the channel by head, so we can see how matrix multiplication changes, and actually it's actually it's same with how group network is working. This is how multi-attention works. There will be W about W, Q, K, V, and O. And we split Q, K, V for each of the head. And we make it together again and give an output. So this is in attention paper. We can see when layer increases, BLEU increase, issues potentially we could get a lot of dataset layer. But as I told you before, RLN is coming back because of several reasons. Multilingual and multi-source, and for model compression and large context inference, and pre-training and fine training is the very important thing. When we use it for we call it also transfer learning and downstream task. For me, I did computer vision project last 2024, and there was problem when we use YOLO. We used to YOLO, but we use it from the first, which means we are starting it from random weight. So we can have different result with what SOTA shows. So the best way is actually just fine tune the model. And so if you see the transformer architecture, they use self-supervised learning, which is automatically make the task by using the label. And fine tuning is important. When we do fine tuning, important thing is make effort on learning, right? Small, unless we could broke the parameter. And another interesting question I had was, can we not really change it like we changing the code? And the answer was no, because because it is not modular architecture like programming language. So what we need is maybe neural architecture or FGD tuning. This is not modular. Yeah, not modular network. There was good keyword. What was it? It is because not a. It's because not a modular network. Yeah, not a modular network, and we don't use token and digit, but we not use symbolic things, but what we use is more like matrix multiplication and real number. But I think I didn't understand real matrix multiplication and real number. I understand this part, so I'm gonna go deep later. So right now what we are doing is doing pre-training the things, and Transformer has encoder and decoder, but these days we just use decoder model like ChatGPT. We say context learning, which is observed without fine tuning. In language models are few shot learning paper. If we see the paper together, then what they are saying is, if you give example sentence together to translate from French to English, then maybe it could replace encoder. And these days we sometimes call it prompt engineering. So how can we put things then GPT just to make output? So in Transformer, the important thing is mask self-attention and feedforward network. A layered normalization and residual network is used for modern neural network architecture these days. And we can think of how NVIDIA also has very high margin rate, because they are price policies based on memory price. And if GPU memory requirement, minimum GPU memory requirement doesn't satisfy, researchers can't even run the model. That's the issue with researchers and developers should buy NVIDIA's expensive GPU memory. And so what basically GPT is doing is big parameter. There is theoretical background, which is in paper deep double descent. They shows in statistics, people do, if parameter is larger, there should be overfitting. But deep double descent shows deep double descent and scaling law shows performance. The learning time and data set and number of parameter is best for minimize the cost, not algorithm. So these days, model compression also goes important together. So if this kind of flow continues, then model compression will be very important. But there's also reasoning come out, so we don't know how things are changed. So basically, so for transformer, what is important is self-attention and feedforward network. And this is part of this center of the layer, and there is feature dimension, and there is input layer and output layer. Thank you very much today.